Let's take a look on how to texture a cube, and the end result will look like this. So we will have a cube and each side will be textured with this cat PNG file, and as you can see it also has this transparency. So the first thing you will need to change is the vertex buffer. So here are the vertices, or the vertex buffer. So now, as you can see, in each row I have 8 values. So for the vertex position, so XYZ, the next 3 is the RGB color, and the last 2 is the texture coordinate. So, and now we have 6 of these planes, so 1 plane, 2 plane, and the third plane, 4th, 5th and the 6th plane, forming this cube. And here are also changed the indices. And to actually properly draw a textured cube, you need to have at least 24 vertices. I'm going to show you the wrong way of doing this by having just 8 vertices, so 2 planes. How it looks like. Now, as you can see, the front and the back face is properly textured, but the side faces are not properly textured. So on the sides, the texture is just this stretch, is totally stretched. So that's why you need at least 24 vertices to properly texture a cube. Okay, go back to this file. And one more time, in each row we have a vertex position, so XYZ, its color, and the last 2 is the vertex texture coordinate for this. So, and to actually set the vertex attribute pointer, now we need to include also these 2 values. So here down, now I'm enabling the vertex attrib array at layout location 2 in the vertex shader, and I'm also setting the vertex attrib pointer for the layout location 2, which will be of vector 2. So here we specify as a second argument that it will be a vector 2 of type GL float, and values are normalized or not, so GL false or should be normalized, and this is the offset and this is the stride. So the stride is the vertices that item size times 8, which means in each row we have now 8 values. So 1, 2, 3, 4, 5, 6, 7 and 8. And the vertices that item size returns 4, because each of these value is 4 bytes in size. So 4 times 8 is 32, so the stride is now 32 for each of these vertex attrib pointer. And the offset for the textures is C-type the C-void pointer and 24. So the textures starts at the 24th byte. So here in this buffer you need to go, or the program need to go 24 byte offset to actually find the texture coordinate values, and after the next 24 byte it finds the next texture coordinate, and so on. So now we have vertices that item size times 8, and for each, so these are the positions in the buffer. The next setting is the color, and the last setting or vertex attrib pointer setting is the texture coordinate. And now let's go here to the vertex source, because now we have also a layout location equals 2, which is an input of type vector 2 called attribute underscore texture. So, and as you can see, it is on the layout location 2. So when we set the vertex attrib pointer, first we enable the vertex attrib array at layout location 2, and then we are setting the vertex attrib pointer for the layout location 2. And here we specify that it is a vector 2, and as you can see it is a vector 2 in the vertex shader. And then here I'm specifying an output of type vector 2 called v underscore color, or I mean v underscore texture, and the v stands for varying, because in the main function the v underscore texture is set to the attribute underscore texture, so to this one, and because it is an output, it is passed from the vertex shader to the fragment shader. And these two lines are commented out, but I'm going to talk about this a little bit later. So that now we passed the texture coordinates from the vertex shader to the fragment shader. Here we are creating an input vector 2 of type v_texture, so this has to be the same name as here the output vector, so v_texture and v_texture. And now we also have here an uniform of type sampler2d called s_texture, and the s stands for sampler. And the sampler2d just stores the image data, so the sampled image pixels. And here in the void main function, now we are setting the output color to the texture function of the sampled texture and the texture coordinates. So the first argument is the sampler2d called s_texture, and the second argument is the v_texture, which is the the texture coordinates. And this texture function, if you go to here to the book of shaders, here, so the first parameter specifies the sampler to which the texture from which texels will be retrieved is bound. It's not very clear. Okay, the second parameter specifies the texture coordinates at which texture will be sampled. So the first is the sampler and the second is the coordinates. And he uses this texture2d, which is, I think it's now deprecated, but if you want, you can also use here, you can change this to texture2d and it will work. But I'm going to leave it as texture, just the texture function, which does the same as texture2d. And here the texture2d function returns a texel, the color value of the texture for the given coordinates. Okay, the function has one input parameter of type sampler2d and one input parameter of type vector2 sampler, which are the coordinates, the uniform the texture is bound to. Okay. Now, let me continue. So these are the changes in the vertex and in the fragment shader. And here are the other changes. So now we are setting a texture here by calling the glgen textures. And we are binding this texture. And here, in this part, we are setting the wrapping parameters and also the texture filtering parameters. And the wrapping parameters for the texture2d is on the S and also on the T, here which is the same as UV in, let's say in Blender, you have U and V coordinates, but these are also called S and T coordinates. So we are setting it to GL repeat mode. And if you want to know more about it, I'm going to add this link to the description. So after you bind the texture2d, here are the GL repeat. The integer part of the coordinate will be ignored and a repeat pattern is formed. You can also set it to GL mirrored repeat. The texture will also be repeated, but it will be mirrored when the integer part of the coordinate is odd. So here are the GL repeat and GL mirrored repeat. And here the clump to edge. Yeah, we are not using clump to edge. So clump to edge, you can also set it to clump to edge, and here is the how it affects the image. The coordinate will simply be clumped between 0 and 1, and here is also the clump the border. The coordinates that fall outside the range will be given a specified border color. So this is the fourth image. So we are using the GL repeat, which is this one image. And here, for the filtering parameters, we are also using the same functions, so the GL text parameter I, the GL texture2d, and now we are setting the minimizing filter, or the, not the minimum, but the minifying filter, and here the magnifying filter to GL linear. And let me see, here it is. So you can set it to the filtering, you can set it to GL nearest, returns the pixel that is closest to the coordinates. We are using the GL linear, which returns the weighted average of 4 pixels surrounding the given coordinates. And here also GL nearest mipmap, nearest GL linear mipmap, nearest, and all sorts of other settings. And as you can see, here is the GL nearest and here is the GL linear. I'm going to add this link to the video description and also this link from the learnopengl.com. Because these guys, it is written and it is much better explained than I can do. So let's continue here. Okay, so let's take a look at the actual image loading. So we are going to use the PIL's image module, so you can import it like this from PIL import image and the PIL with capital letters. And so now with this module here, we can use the image.open, and it is in the texture folder and it's called cat.png. And the next thing we need to do is actually flip this image top to bottom, because I'm just going to show you what happens if I comment out this line. And also in the Vertex shader, I'm just going to remove now the rotation matrix so that we have just a still image. So as you can see, without flipping it on top to bottom, the image is upside down. And this is because the images, these PNGs and all the JPEGs and all the type of images, the image starts at the top left corner, so it's coordinate system. But the OpenGL's coordinate system starts at the low left corners, so the bottom left corner. So that's why this image is flipped. So to actually to actually transpose it, we can use the image.transpose method from a PIL module and give it the image.flip top to bottom. And now when I run it, the image is correctly displayed. So the next thing we should do, but first of all, let me stay by this line a little bit, because these are these two lines in the Vertex shader I wanted to explain you. So if you are not using PIL, but if you are using OpenGL with C or C++ or any other language, and you don't have this transpose functionality or something like that, you can also do this transpose inside. So now we have upside down the image. You can also do this transpose inside the Vertex shader. And so this is I'm going to comment out this line and use this second line, which sets the v underscore texture equal to 1 minus a underscore texture. And this flips the image, the texture vertically and also horizontally. So now it is flipped, but his tail is now pointing to the left. And in the original image, as you can see, its tail is pointing to the right. So because it flips also, as I said, vertically and also horizontally. If you want to flip this image only on the vertical, I'm going to comment out this line and uncomment this line. You can set it like this. So v underscore texture equals a vector 2 of a underscore texture.s, and this is called swizzling. So because these are vector 2s, you can just use it like vector 2.x, vector 2.y, vector 2.s, or vector 2.t, or vector 2.r, vector 2.g for RGB. So which means that that s will remain unchanged, but in the t we are going to subtract 1 minus a underscore texture.t, and this flips it only on the vertical axis, not on the horizontal axis. So this is how you can flip the image or transpose the image inside the Vertex shader. But I'm going to actually comment out this and use it as I used it before with the image.transpose, image.flip top to bottom. Okay, so let's go further, and now we need to have the raw image data, and we can do this with the image.convert method and converting to an RGBA, because this is an RGBA. It is 32-bit color, which means it has 8-bit for red, 8-bit for blue, 8-bit for green, and 8-bit for alpha channel, for the alpha. And here, calling on it the 2 bytes method, which just converts the image data to bytes format. So in the GL texture image 2D, we can actually use this. And let me see how this GL text image 2D works. So if I go here, as you can see, here are all the parameters. So the target specifies the target texture, which is set to GL texture 2D. The second argument is the level, specifies the level of the detail number. Level 0 is base image level, and the level n is the nth mipmap reduction image. So this is for the second argument, which is set to 0, is the mipmapping. This is the internal format, which is set to GL RGBA. The next is self-explanatory, because this is the image width and this is the image height. And after the image height, so width, height, this is the border, specifies the width of the border, must be either 0 or 1, and we set it to 0. And here also we need to specify GL RGBA, which is the format, specifies the format of the pixel data, and so on. And this is the type, specifies the data type of the pixel data, and the following symbolic values are accepted. We are using the GL unsigned byte. So GL unsigned byte, because here we just converted it to unsigned bytes. And the raw image data, so image data from here. And yes, to actually see the transparency on this image, you should enable also the GL blend and set the GL blend func to GL underscore source underscore alpha and GL underscore 1 minus SRC alpha. So without these 2 lines, it is not transparent anymore. So if I set here back the rotation matrix, so rotation times the vector 4 position. Now, as you can see, it is a solid cube and there is no transparency. So that's why you need to set here that enable GL blend and blend func to GL source alpha and GL 1 minus source alpha. And one more thing, if you want to use JPEG image, let's say here is this create that JPEG. I'm just going to change it here, so create that JPEG. It is just create the JPEG. Don't forget to change all of these RGBA to, let me see if it will work or not. And it works. Yeah, it works. I thought that it won't work. But technically, if you are using JPEG, you should just use RGB, here RGB, and here also RGB. And let me take another look for this smile.png, which is a PNG image, but it is a 24-bit image. So technically, it has no alpha value. So smile.png. So, as you can see, it has this strange black and white result, although it has no alpha value, but you should set it to G here, RGBA, and here also in the texture image, RGBA and RGBA, to actually correctly draw this texture. So, I'm going to change it back to cat.png, and of course this file is will be also uploaded to my GitHub page, and the link will be in the description. So this is how you can properly texture a cube. And In the next video, I'm just going to show you how to do this same scene inside Pygame, because I know that many of you want to use OpenGL with Pygame. So from time to time, I'm just going to do some Pygame examples.